Hello and welcome to Astronomy Daily, your source for the latest and most fascinating developments in space exploration and astronomical discoveries. I'm your host, Anna, and I'm excited to guide you through today's cosmic journey. We have a stellar lineup of stories for you today. We'll be exploring NASA's Deep Space Network as it celebrates 60 years in Australia while breaking ground on a new radio antenna. Then, we'll look at Saturn's rings as they present a rare edge-on view that occurs only every 14 to 15 years. We'll also cover this week's busy launch schedule, including Amazon's Project Kuiper satellites and Blue Origin's first all-woman crew. Plus, we'll examine the growing commercial demand for lunar landers beyond NASA and dive into a breakthrough discovery about the origin of black hole magnetism that solves a long-standing cosmic mystery. So strap in as we blast off into today's exploration of our fascinating universe. Here we go, with one for our Aussie listeners. NASA's Deep Space Network in Canberra, Australia recently celebrated a significant milestone, its 60th anniversary. This celebration came with an exciting development as the facility broke ground on a new radio antenna, marking the beginning of its next chapter in space communications. The Canberra facility has been a vital part of NASA's global communications network since joining in 1965. Currently operating 4 massive radio antennas, the addition of this fifth dish represents a crucial expansion of the network's overall capacity to handle the ever-increasing flow of data from missions across our solar system. This new antenna, designated Deep Space Station 33, will be a marvel of modern engineering. At 112 feet wide, that's about 34 meters, this multi-frequency beam waveguide antenna will significantly boost the network's capabilities. What makes this design particularly interesting is that most of its structure will actually be buried underground. A massive concrete pedestal will house cutting-edge electronics and receivers in climate-controlled rooms, providing a solid foundation for the reflector dish above. When operational, the dish will rotate during communications on a steel platform called an alidade, allowing it to track spacecraft as they move across the sky. This sophisticated design ensures reliable communication with distant spacecraft exploring the farthest reaches of our solar system. Kevin Coggins, Deputy Associate Administrator of NASA's Space Communications and Navigation Program, highlighted the significance of this development, noting that as they look back on 60 years of incredible accomplishments at Canberra, the groundbreaking of this new antenna symbolizes the next 60 years of scientific discovery. The construction of such advanced communication technology demonstrates the Deep Space Network's commitment to embracing new technologies that enable exploration by an expanding fleet of space missions. The new Canberra dish is expected to go online in 2029 and will be the final installation of 6 parabolic dishes constructed under NASA's Deep Space Network Aperture Enhancement Program. This program is specifically designed to support current and future spacecraft and accommodate the increasing volume of data they transmit back to Earth. Similar upgrades have already taken place at the network's Madrid facility, which christened a new dish in 2022, while the Goldstone facility in California is completing work on another antenna. The Deep Space Network operates through a brilliantly simple yet effective concept. 3 communication facilities positioned strategically around the globe, approximately 120 degrees apart. This careful placement ensures that as Earth rotates, at least one facility always has line of sight to any spacecraft in our solar system, providing continuous coverage 24 hours a day, regardless of where those spacecraft may be. The network officially began on December 24, 1963, when NASA connected its early ground stations, including Goldstone, to the new Network Control Center at the Jet Propulsion Laboratory in Southern California. Madrid joined in 1964, followed by Canberra in 1965. Since then, these facilities have been the lifeline for hundreds of space missions, including historic achievements like the Apollo moon landings. What makes Canberra particularly special is its location in the Southern Hemisphere. This unique positioning grants it an exclusive capability. It's the only facility that can both send commands to and receive data from Voyager 2 as it journeys southward through interstellar space, now almost 13 billion miles from Earth. Its sister craft, Voyager 1, which is even more distant at over 15 billion miles away, can transmit data to the Madrid and Goldstone complexes, but can only receive commands via Canberra. The Deep Space Network currently relies primarily on radio frequencies for communication, but NASA is looking toward the future with exciting new technologies. The agency is experimenting with laser, or optical communications, which operates at significantly higher frequencies than radio. This difference is crucial because higher frequencies allow for substantially more data to be transmitted over the same period. This advancement isn't just theoretical. NASA is actively testing it through the Deep Space Optical Communications experiment aboard the Psyche mission launched in October 2023. The results have been impressive, demonstrating record-breaking high data rates over unprecedented distances and even successfully downlinking ultra-high-definition streaming video from deep space. These new technologies have the potential to boost the science and exploration returns of missions traveling throughout the solar system, explained Amy Smith, Deputy Project Manager for the Deep Space Network. Looking further ahead, researchers envision combining laser and radio communications to create hybrid antennas, dishes that can communicate using both radio and optical frequencies simultaneously, potentially revolutionizing how we communicate with distant spacecraft. As our exploration of space grows more ambitious, with missions venturing further into the solar system and returning increasingly complex scientific data, the Deep Space Network continues to evolve to meet these demands, ensuring that humanity maintains its connection to our most distant explorers. Astronomy fans, here's one for you. If you've looked at Saturn through a telescope lately, you might be wondering where those iconic rings went. The ringed planet is looking distinctly ringless these days, thanks to a fascinating astronomical alignment that happens only once every 14 to 15 years. Saturn's rings have turned edge-on, as seen from Earth, rendering them nearly invisible even through powerful telescopes. This phenomenon is tied to Saturn's 29.5-year orbit around the Sun. The planet's magnificent rings are tilted 27 degrees with respect to its orbital plane, which means that from our earthly perspective, our view of the rings cycles from wide open to edge-on and back again over roughly 15-year intervals. The rings were last edge-on to Earth on March 23rd, and they'll be edge-on to the Sun on May 6th. What makes this disappearing act so dramatic is the stark contrast between the rings' enormous width and their paper-thin profile. While Saturn's rings span an impressive 282,000 kilometers across, that's almost 3/4 of the distance from Earth to the Moon, they're astonishingly thin, averaging just about 100 meters in thickness. So when we view them exactly edge-on, they essentially vanish from sight. Galileo was the first to observe Saturn's rings in 1610, though with his primitive telescope, he couldn't quite make out what he was seeing. His sketches show a strange twin-lobed world that resembled a double-handled coffee cup, a testament to the limitations of early astronomical equipment. It wasn't until later that Christian Huygens correctly deduced that these handles were actually rings completely detached from the planet itself. Today, we understand that Saturn's rings consist primarily of countless ice particles ranging from snowball-sized to much larger, along with some rocky debris. And while every gas and ice giant in our solar system has some form of ring system, none are as spectacular or as visible from Earth as Saturn's. Perhaps the most surprising discovery about Saturn's rings in recent years is their relative youth. Several studies now suggest that the rings may be a surprisingly recent addition to the planet, possibly forming just 10 to 100 million years ago, practically yesterday in cosmic terms. This means that if dinosaurs had somehow developed telescopes, they might have observed a rather ordinary-looking Saturn without its distinctive halo. Even more intriguing is the ring's limited future. Scientists predict that in the next few 100 million years, the rings will gradually dissipate from view as gravitational forces pull their particles either into Saturn itself or fling them outward into space. We're actually witnessing Saturn during a special period when its rings are at their most magnificent, a cosmic coincidence that makes our era particularly fortunate for astronomical observation. So while Saturn might look a bit bland during this edge-on phase, take heart. The rings are still there, and they'll gradually become visible again as the viewing angle changes, reaching their maximum tilt once more in 2032. Sometimes in astronomy, the most fascinating phenomena are not what appears, but what temporarily disappears. April offers some excellent opportunities for early risers to spot Saturn, despite its temporarily ringless appearance. If you're hoping to observe this unusual sight, Venus will be your best guide in the dawn sky. Shining brilliantly at magnitude -4.6, Venus outshines Saturn by over 100 times, making it an unmistakable beacon pointing the way to the more subdued Saturn, which currently glows at magnitude +1.2. Mercury completes this planetary dawn trio, reaching its greatest elongation 27 degrees from the Sun on April 21st. Mark your calendar for the morning of April 25th, when the waning crescent moon joins this celestial gathering in the eastern sky. While the moon won't pass directly in front of Saturn during this particular alignment, it creates a beautiful photo opportunity for astrophotographers and a striking visual for casual observers. If you're interested in seeing a lunar occultation of Saturn, you'll need to wait until April 24th, 2031. Astronomy often rewards patience. For telescope owners, this ring plane crossing period offers a rare observing opportunity. With the rings essentially invisible, you can enjoy unobstructed views of Saturn's moons as they transit across the planet's disk. These transit events, where moons pass in front of Saturn from our perspective, are commonly observed on Jupiter but are only visible on Saturn during years when the rings are edge-on. Titan, Saturn's largest moon, is particularly worth watching as it casts a prominent shadow during its transits. These events occur approximately every 16 Earth days as Titan completes its orbit, though catching one requires being in the right location at the right time, as each transit lasts about 5 hours. Specialized websites like PDS Rings Node and IMCCE France provide predictions for these events, or you can use astronomy software like Stellarium to check for upcoming transits before planning an observation session. As the year progresses, Saturn will reach quadrature west of the Sun on June 22nd, an excellent time to observe the planet casting its shadow across what remains visible of the rings, creating a striking three-dimensional appearance. After reaching opposition on September 21st, Saturn will transition back into the evening sky. By the end of 2025, the rings will have tilted about 1 degree open to our line of sight, and they'll continue widening until they reach their maximum tilt again in 2032. Saturn's unique orientation affects not just its appearance, but also its brightness, with the current edge-on view reducing its magnitude to +1.2 compared to -0.54 when the rings are fully tilted toward Earth. Let's look at this week's busy launch schedule next. This week is shaping up to be a remarkably active period in spaceflight, with 5 major launches taking place across multiple launch providers and mission types. The action begins with United Launch Alliance's Atlas V rocket, which is set to lift off on April 9th at 7 p.m. Eastern Time from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida. This mission carries special significance, as it will deploy the first operational batch of Amazon's Project Kuiper satellites, marking a major milestone for the Internet Constellation program. The Atlas V will be flying in its most powerful configuration, designated 551, featuring a 5-meter fairing, 5 solid rocket boosters, and a single-engine Centaur upper stage. This robust setup is necessary to handle what will be the heaviest payload ever launched by an Atlas V, 27 Kuiper satellites bound for low Earth orbit at an altitude of 450 kilometers. SpaceX dominates the middle portion of the week with a trio of Falcon 9 launches. First up on April 10th at 9:43 p.m. Eastern Time is a Starlink mission designated Group 12, 17, carrying approximately 20 Starlink V2 mini satellites. This launch will depart from Launch Complex 39A at Kennedy Space Center, sending the satellites on a southeastern trajectory to an orbit inclined at 43 degrees. Just 2 days later, on April 12th, SpaceX shifts operations to the West Coast for a national security mission. A Falcon 9 will lift off from Vandenberg Space Force Base in California at 5:17 a.m. Pacific Time, carrying a classified payload designated NROL 192 for the National Reconnaissance Office. While details remain classified, this is believed to be the 9th SpaceX mission deploying Starshield satellites for reconnaissance operations such as Earth imaging and early missile warning detection. SpaceX rounds out its busy schedule with another Starlink launch on April 13th at 9:59 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral. This mission, Starlink Group 673, will deliver another batch of approximately 20 V2 mini satellites to the same 43-degree inclined orbit as the earlier Starlink launch. The week concludes with Blue Origin's New Shepard rocket taking flight on April 14th at 9:30 a.m. Eastern Time from Launch Site 1 in West Texas. This suborbital mission, designated NS-31, will carry a historic all-woman crew of 6 passengers: Aisha Bowe, Amanda Nguyen, Gail King, Katy Perry, Carrie Ann Flynn, and Lauren Sanchez. The flight will take the crew above the internationally recognized Kármán line at 100 kilometers, allowing them to experience several minutes of weightlessness before returning to Earth approximately 11 minutes after launch. The lunar economy appears to be gaining momentum as companies involved in NASA's Commercial Lunar Payload Services (CLPS) program report increasing interest from customers beyond the space agency. While NASA funding still accounts for about 90% of mission costs, the remaining 10% comes from a diverse group of clients that includes international space agencies, universities, private companies, and even rideshare customers. Intuitive Machines, which successfully landed on the moon in March with its second lander, is seeing tangible growth in commercial demand. According to Trent Martin, the company's senior vice president for space systems, the commercial market is real and it's growing. This shift suggests we're witnessing the early stages of a sustainable lunar marketplace rather than just government-subsidized missions. These companies are finding that data gathered during scientific missions creates pathways to future commercial opportunities. David Wheeler, general counsel at Firefly Aerospace, points out that current activities like regolith sample collection serve as precursors for resource extraction and mining. Similarly, Ananda Martin of iSpace Technologies believes the scientific data being collected now will support further phases of lunar development, such as extraction and eventually human habitation. Although a report released last November by the Center for Strategic and International Studies found no indication of a lunar gold rush, industry insiders maintain that commercial interest is steadily increasing. They argue that the economics will improve with each successful mission as lunar flights become more affordable and less risky. International space agencies are already participating in these commercial ventures, albeit at a smaller scale than NASA. As Trent Martin explained, they don't have $150 million to fund a mission, but maybe they have $10 million to fund a small instrument that they want to fly on the lander. Intuitive Machines has secured multiple contracts with foreign space agencies to carry payloads on future lunar missions. Companies are also discovering unexpected business opportunities along the way. Intuitive Machines has found additional revenue streams by offering orbital transportation services for satellites and creating a lunar communications network. When rideshare customers on their recent mission experienced difficulties communicating with their satellites at lunar distance, they turned to Intuitive Machines for help, revealing a new market need. The emerging picture suggests that while we're not yet seeing a full-fledged commercial lunar ecosystem, the foundation is being laid through these initial CLPS missions. With each successful landing, these companies are building technical capabilities, operational experience, and business relationships that could eventually transform lunar activities from primarily government-funded scientific endeavors into a sustainable commercial enterprise. Finally today, one of the most enduring mysteries in astrophysics has finally been solved, revealing the origin of the powerful magnetic fields that enable black holes to create spectacular cosmic fireworks. Scientists at the Flatiron Institute and their collaborators have discovered that these magnetic fields are inherited directly from the dying stars that give birth to black holes. Black holes are known primarily for their immense gravitational pull that traps everything nearby. However, they can also produce intense jets of charged particles that generate gamma-ray bursts, explosive events that release more energy in seconds than our sun will emit across its entire lifetime. These phenomena require extremely strong magnetic fields, but until now, the source of this magnetism remained elusive. Through detailed computer simulations tracking a star's evolution from collapse to black hole formation, researchers identified the critical mechanism at work. As a massive star explodes in a supernova, it leaves behind a dense core called a proto-neutron star. When this proto-neutron star collapses to form a black hole, its magnetic field doesn't simply disappear. Instead, it transfers to the disk of swirling matter that forms around the newborn black hole. Protoneutron stars are the mothers of black holes, explains Or Gottlieb, the study's lead author. What we are seeing is that as this black hole forms, the protoneutron star's surrounding disk will essentially pin its magnetic lines to the black hole. This discovery resolves a significant theoretical paradox that had puzzled scientists. Previous theories suggested that magnetic fields were compressed during stellar collapse, enhancing their strength. However, such strong magnetism causes stars to lose their rotation, and without rapid rotation, a black hole can't form the accretion disk necessary to produce jets and gamma-ray bursts. The team's calculations revealed a critical timing element. The black hole's disk forms faster than the black hole can lose its inherited magnetism. This sequence preserves the magnetic field lines from the parent neutron star, anchoring them to the black hole's accretion disk. The implications extend throughout astrophysics, potentially changing how scientists understand jet formation in various cosmic systems. As Gottlieb notes, this study changes the way we think about what types of systems can support jet formation, because if we know that accretion disks imply magnetism, then in theory, all you need is an early disk formation to power jets. This breakthrough helps explain how black holes can generate the most luminous explosions in the universe and provides a comprehensive picture of these extraordinary cosmic objects from birth to maturity. Previous theories about black hole magnetism painted an incomplete picture. Scientists had long thought that as stars collapsed, their magnetic fields were simply compressed and intensified. But this explanation created a fundamental paradox that had astronomers scratching their heads for years. The problem was this: a strong magnetic field causes a star to lose its rotation, and without rapid rotation, a newborn black hole can't form an accretion disk, that swirling collection of matter that surrounds it. Without an accretion disk, you can't get the powerful jets that produce gamma-ray bursts. So how could black holes have both the strong magnetic fields and the accretion disks needed for these spectacular cosmic phenomena? Gottlieb's team realized that past simulations had missed something crucial. They'd only considered isolated neutron stars and black holes, ignoring the complex interactions between them during the collapse process. The key insight was recognizing that neutron stars have their own accretion disks before they collapse. It appears to be mutually exclusive, Gottlieb explains. You need two things for jets to form: a strong magnetic field and an accretion disk. But a magnetic field acquired by such compression won't form an accretion disk, and if you reduce the magnetism to the point where the disk can form, then it's not strong enough to produce the jets. The new calculations revealed a solution to this puzzle. As a neutron star begins to collapse, but before all its magnetic field is swallowed by the forming black hole, the neutron star's disk is actually inherited by the black hole. During this process, the magnetic field lines become anchored in the disk, preserving the magnetism even as the central object transforms. It's a bit like a cosmic inheritance. The mother neutron star passes down its magnetic genes to its child black hole through the medium of the accretion disk. This transfer happens because the timescale for disk formation is shorter than the timescale for magnetic field dissipation. This discovery fundamentally changes our understanding of black hole formation and jet production. It suggests that any system where an accretion disk forms quickly enough could potentially support jet formation. The researchers are now reconsidering various types of stellar systems and their potential for generating these powerful cosmic phenomena. The work demonstrates the power of multidisciplinary collaboration and advanced computational resources. By bringing together experts from different fields and running more comprehensive simulations than ever before, the team was able to see connections that had previously been missed. Well, that brings us to the end of another fascinating episode of Astronomy Daily. From the expansion of NASA's Deep Space Network in Australia to Saturn's rarely seen edge-on rings, we've covered some truly remarkable developments in our cosmic neighborhood. The busy launch week ahead promises to push human exploration further, while commercial lunar lander companies are finding growing interest beyond NASA's missions. Perhaps most exciting was our look at the breakthrough in understanding black hole magnetism, solving a paradox that has puzzled scientists for years by revealing how these cosmic monsters inherit their magnetic fields from their mother neutron stars. The universe continues to surprise us with its complexity and beauty, reminding us why astronomy remains one of the most captivating scientific pursuits. I'm Anna, and I've been your host for this edition of Astronomy Daily. If you enjoyed today's episode, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and listen to all our back episodes. It's the perfect way to stay informed about the latest astronomical discoveries and space exploration news. You can also find us across social media by searching for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, and TikTok. Share your thoughts about today's topics or suggest subjects you'd like us to cover in future episodes. Until next time, keep looking up. There's always something amazing happening in our cosmic neighborhood.